Welcome to Level 1 Mechanics, and this chapter is on forces. Force is a push, pull, or twist, and it is a push, pull, or twist that causes acceleration. Okay, if there is acceleration, there's got to be a force. Remember that. Acceleration and force go hand in hand. Forces are measured in newtons, and the newton is symbolized by the capital N. Formula for force is F equals m times A, where F equals force, makes sense, and the unit for force, of course, is the newton. Mass is symbolized by the letter M, and the unit for mass is kilograms, and the A in the formula stands for acceleration and is measured in meters per second squared. Alright, let's try an example. A cyclist accelerates forward at 1.5 meters per second squared. If the bicycle and rider have a combined mass of 80 kilograms, what is the net force on the bike? So, as with all problems, you should write down what you know and what you're trying to find out. Alright? So in this case, force is what we're looking for, because the question asks, what is the net force on the bike? Mass is 80 kilograms, and it says that right in the question. And A is acceleration, and that is 1.5 meters per second squared. So we take our handy dandy formula, F equals m times A, and we plug our numbers into that formula. So we got F equals 80 kilograms times 1.5 meters per second squared. And F equals 120. Make sure you write your units in every question that you do a calculation in. If you don't, you could lose out on some marks. In this case, of course, force equals, or the unit for force is newtons, so 120 newtons. Alright, let's try another example. This one's a little bit more complicated. It's going to take 2 steps, but you should be able to handle it. You've done this before. So in this question, a 1,000 kilogram car accelerates from 8 meters per second to 12 meters per second in 8 seconds. What force produces this acceleration? So again, we're looking for force, so that's where our question mark goes. That's what we don't know. Okay, what we do know is its mass is 1,000 kilograms. It's right there in the question. Always read your questions. And acceleration, we look here, it says accelerates, but it doesn't actually give us the acceleration, so that's another question mark. So if I've got 2 question marks, so we don't know F and we don't know A, we can't use that equation yet. Okay, we're going to have to find out the answer to A first, or determine what A is. So if you take a look at the question, we've got 8 meters per second to 12 meters per second. So this car has increased speed by 4 meters per second from 8 to 12 meters per second. In the question we also have time. Alright, and that's 8 seconds. So we put our values in, 4 meters per second and 8 seconds. So if we take a look at our formula sheet, you will find a formula that has A, delta V, and delta T in it. And of course that is A equals delta V over T. And hopefully you remember that delta V, which is that triangle, is change in speed. Alright, so we start off step 1. We use the A equals delta V over T. We put our numbers in. A equals 4 meters per second divided by 8 seconds. Punch that into our calculator, or if you got a big brain, just it doesn't even have to be a big brain, and you can calculate that in your head. And that is 0.5 meters per second, so half a meter per second squared. So now we know acceleration, we can put that there. Alright, now we can use this formula, F equals m times A, because we know A and we know m. We can solve for F. So force equals 1,000 kilograms, that's the mass of the car, and of course we take that 0.5 meters per second from over there, plop it right in our formula, and you can see that 1,000 times 0.5 meters per second squared it's going to give you 500 newtons. Okay, the force formula, we can use a magic triangle with this, because sometimes we're going to want to solve for M or A, and not necessarily F. So you can see M times A. So if we're going to put M and A into this triangle, we have to put them at the bottom of the triangle so that we can get an M times A. If we put an M up here and an A down here, it's always going to be divided by, but you wouldn't be able to get M times A. So we have to move that over there. Okay, in your exams, you will get the formula, but you won't get this magic triangle, so you have to know how to make this magic triangle. So there's only one space left, and that's force. We move that over there. So there's our triangle. And we can double check this. If we cover up F, we can see that F equals M times A, just as it is here. Alright, but if we want to solve for A, for example, we take our finger, cover up A, and that tells us A equals F divided by M. If we wanted to solve for mass, M, we cover up the M, and we can see that M equals F divided by A. Again, all simple, easy to do. Let's try an example. Alright. An ostrich legs provide a force of 190 newtons, which allow the ostrich to accelerate at 2.0 meters per second squared. What is the mass of the ostrich? Alright, so let's write down what we know and what we don't know. We know the mass of, the force is 190 newtons, and we don't know the mass because that's what the question's asking us. What is the mass? But we do know the acceleration, so we put that down. Now, if we take a look at our magic triangle, our question mark is on the M, so we cover up the M in the magic triangle. M equals F divided by A. Now we just take our numbers, put them in there, and it is M equals 190 newtons divided by 2.0 meters per second squared. And we get an answer of 95 kilograms. And that's how you do it.